Today, we're diving into one of the most powerful and honestly most common pieces of equipment in the entire world. It's this unseen engine that literally powers our modern life. We are talking about the boiler. Oh, you've definitely felt its work before. You know, from the heat in your apartment building to making sure instruments are sterile in a hospital. Even the steam that presses clothes at the dry cleaner or the heat in a bakery's oven. The humble boiler is almost always the invisible force behind it. So, what is a boiler really? Well, at its core, it's a closed, pressurized container that heats up water. And that creates either hot water or, more often than not, really high-pressure steam. They're actually one of the oldest forms of pressure equipment out there. And trust me, when they're not respected, they can be one of the most dangerous. To really get how it all works, try not to think of it as just a simple tank. It's more like a supercharged industrial kettle, one that's designed to turn pure heat into raw, usable force. It's all about this powerful, continuous cycle. So first up, combustion. You burn a fuel, say natural gas, to create a ton of heat. Then, that heat gets transferred through these metal tubes right into the water that's held in the boiler's shell. As that water boils, it creates high-pressure steam, which then gets piped out to do its job. And finally, if it's a closed-loop system, that steam cools down, condenses back into water, and just returns to the boiler to start the whole cycle all over again. Now, what's really fascinating is how engineers have kind of flipped this design around for different purposes. So in a fire tube boiler, you've got hot gas from the fire flowing through tubes that are surrounded by water. That's perfect for smaller places, like a brewery. But for huge power plants, they reverse it. They use water tube boilers, where the water flows through the tubes and the hot gas surrounds them. The key difference is just this: is the fire in the tubes or is the water in the tubes? It's all about getting the most heat transfer for the size you need. And then, of course, you have modern condensing boilers, which are just incredibly efficient because they actually capture extra heat that would normally just go right up the chimney. Okay, so a boiler has a lot of crucial parts, you know, from the big steel shell to the burner itself, and the water level gauge is absolutely vital. And we'll see exactly why in just a minute. But the single most critical component, the absolute last line of defense against a disaster, is the safety relief valve, or SRV. Its one and only job is to pop open automatically if the pressure inside gets dangerously high. And that brings us to the really serious side of all this. See, a boiler contains just an enormous amount of stored energy. And when that energy gets released uncontrollably, the results, well, they can be catastrophic. So what is the number one thing that causes these failures? Now look, a few things can go wrong. A safety valve could be blocked, or maybe just bad maintenance. But there is one single cause that stands way above all the others. The one issue responsible for more catastrophic boiler failures than pretty much anything else combined. Low water level. It's that simple and it's that deadly. Here's why. If the water level drops below those heating surfaces, those really hot tubes, the metal isn't being cooled anymore. It overheats almost instantly. It loses its structural strength, and it just can't contain that immense steam pressure inside. The result is a violent, devastating explosion. Okay, so that explains the physics of it, but what are the real-world consequences? I mean, what happens when this system fails on a massive scale? For that answer, we actually have to look back in history, to the single worst boiler disaster the world has ever seen. This is the story of the river steamboat, the SS Sultana. The date was April 27, 1865. This was right after the end of the American Civil War. The Sultana was packed, dangerously overcrowded, with Union soldiers who were finally heading home. The problem was, its boilers were in terrible condition and just really badly maintained. In the middle of the night, on the Mississippi River, one of those boilers exploded. The blast and the fire that followed killed approximately 1,800 people. So put that number into perspective for you. Think about the sinking of the Titanic. That happened almost 50 years later, and it claimed around 1,500 lives. The Sultana disaster, caused by a single boiler failure, was even deadlier, and yet it's somehow one of history's lesser-known maritime tragedies. The horror of what happened on the Sultana, it had to be a catalyst for change. And it was. It directly led to the very first boiler inspection laws, and eventually to really robust engineering codes from organizations like the American Society of Mechanical Engineers, or ASME. And those codes now govern the design, construction, and inspection of boilers all over the world, all to prevent something like that from ever happening again. So let's just bring it all together. Boilers are these essential engines that turn heat into real power.
We've learned that the single most critical safety factor is just keeping the water at the proper level. And that safety relief valve, that's your non-negotiable last line of defense. But I think most importantly, as the story of the Sultana teaches us, it's regular inspection and maintenance that truly saves lives.
It really makes you look at them in a whole new light, doesn't it? It's not just some tank. It's a powerful piece of history, and it's a testament to some incredibly hard-won lessons in safety engineering.
And that is exactly the right takeaway. Now, on our next explainer, we're going to look at a totally different kind of pressure vessel, but one you probably walk past every single day without even realizing it. We're going to talk about the compressed air tank, silent pressure that's absolutely everywhere you look.